Hello friends, welcome to DBMS class. In this class, let us discuss a database system concepts and a architecture of a database management system. Okay, so as we know, the database management system is one of the one of the client and server system architecture in the beginning days or in the evolution of database management system, where a large centralized mainframe computers are being used for database management system, but that mainframe computers are nowadays being replaced by hundreds of distributed workstations. Okay, and the personal computers are connected via the communication networks to our various servers where we can access the stored data. Okay, so those servers or those server machines are called as what? Those are called as a web servers, database servers, file servers, and application servers. And so many servers are there. So using those servers, we can connect to the mainframes where we can access the stored database. Okay. So in this chapters, we will learn or we will discuss about data models, schemas, and instance. After that, in the data models, we are going to discuss about categories of data models and what is the meaning of schema and what is the instance and what is the meaning of database states. We'll discuss in this class. And next, after that, we'll discuss about the architecture and data independence, that is database DBMS architecture. And in this architecture, we'll see the three schema architecture of the database management system. After that, we'll discuss about the data independence, and again there are two types of data independence are there. Those are logical data independence and physical data independence. So after that, we will discuss about database languages and interfaces which are used in the DBMS. Okay. So after that, we will discuss about the database system environment, which is consisting of several modules, that is those are like a component modules. And after that, we will discuss about the system utilities of the database system. And next, at last, we will discuss about tools and application environment and communication facilities which are available in the database management or database system environment. So after that, on which categories we will classify the database system management. So we will see how we are going to on what basis we are making a classification of a database management system. Okay. So let us start the first concept, that is data models, schemas, and instance. So as we know, the most important characteristics or fundamental characteristics of the database approach is, so it must provide the level of abstraction. Okay. The main important characteristics of the database is it must provide the abstraction. We already know what is the meaning of data abstraction. So here the data abstraction is the suppression of the details. Okay, it must hide the details of the organization and storage, how the data is organized in the database and how it is stored in the data, how the data is stored in the database. It must hide from the user, but it must highlight the essential features for improved understanding of the data. So this is one of the most or a main important characteristics of the database approach. So this is to support this data abstraction. So users can perceive their preferred level of details. So that means a user the required data can be the required only the required data can be accessed by the users. That is the use of the data abstraction. Okay. So in the data model, a collection of concepts. So the data model can be defined as a collection of concepts that are being used to describe the structure of the data is called as a data model. So to achieve the data abstraction, we are going to use a construct of one data model. Okay. So here data model means a collection of concepts. It is a collection of concepts that can be used to describe the structure of the database. What is the structure of the database? So that can be defined by the data model. So you can ask me one question like, what is the structure of a database? So here the structure of the database means it may be a data type, or it may be a relationship, or it may be constraints. Those are applied on the data. So these are called as the structure of the database. In most of the data models, it may also include the basic operations like specifying the retrievals and updates on the database. This is called as the data model. Okay. See here. So this is a definition of a data model. And after that, see here we are classifying the data models into three types. Those are conceptual data model, representation model and physical data model. These are the three important types of a data model. So here we are categorizing the data models according to the types of concepts they use to describe the database structures. What type of concepts here we are using to describe the data structure or a database structure, based on that we are categorizing the data models. Okay. So here we are categorizing the data models as I shown in the below figure, that is conceptual data model, representation data model and physical data model. Here conceptual data model is also called as a high level data model. Okay, and this physical data model is also called as a low level data model, and this representation data model is also called as a implementation data model. So see, the conceptual data model is also called as high level data model, physical data model is also called as low level data model, and this representation data model is also called as what? This is also called as a implementation data model. And for your examination there will be a questions like define data model and explain the types of data models. Okay, in that case you must explain the all the categories of data models. So as I told, we are categorizing the data model on the basis of the concepts used to describe the database structures. Okay, let us see what is the conceptual data model, what do you mean by physical data models, and what is the characteristics of the representation models. So first one is a conceptual or a high level data models. So here this conceptual or high level data models provides the concepts that those are close to a many. The first one is a conceptual or a high level data model. So this conceptual or a high level data models, it provides the concepts that are close to the way many users perceive the data. That means a conceptual data model describes the database at a very high level, okay, and it is useful to understand the needs and requirements of the database. What is the need of the database and what is the requirement of the database, that is described in this data model, okay, and it is the model, it is used in the requirement gathering process. So requirement means what are the requirements of the users. To collect those requirements, we are going to when we are collecting those requirements, we are going to use this conceptual data models. So in this case, before database designer starts making a particular database, they are going to design the conceptual data model for the database. So next category is a physical or a low level data model. So in this data model provides the concepts, so that describes the detail of how the data is stored on the computers. So as we know, the data stored in the database is stored on where? It is stored on the secondary storage devices like a disk or a tapes in the form of a files or a records. So this data models provides or describes the details of how the data is stored on the computers like a storage medias and like a typically like a magnetic disk. So here the concepts are provided by the low level data models are generally meant for the computer specialists, not for the end users. So end users only, they are going to access the data stored on the database. They are not going to bother about what is the structure, what is the storage used to store the data and what is the storage structure of the data stored on the database. That's why this is mainly meant for the computer specialist, not for the end users. And the next category of a data model is a representational or a implementation data model. So this data model lies between these two data models, okay. So that is implementation or a representational data models. So this data model provides the concepts that may be easily understood by the end users, okay. So this data model provides the concepts which are easily understood by the end users, but are not like how the data is organized in the computer storage, okay. This representation data models hides many details of the data, many details like data storage on the disk, but it can implemented on the computer systems directly. So that is the main thing about the implementation or a representational model which we have to know here, okay. So as we know, in conceptual data models, so it uses the concepts such as entities, attributes and relationship. So this conceptual data models uses the concepts like entities, attributes and relationships. So what is the meaning of entities and what is the meaning of attributes and what is the meaning of relationship? Let us see here one by one. So here entity means that an entity represents a real world objects or a concepts. Here entity means it must represent a real world objects or a concept that is called as an entity, which is really exist in the for the thing which really exists physically exists in the real world, that is called as an entity. For example, employee, okay, for our projects. So these are all come under the entity, okay. And next one is the attribute. So attribute represents some properties of a or some characteristics of a entities. So attribute means, so attribute is a properties or characteristics of a entities that describes an entity is called as a attribute. So for example, consider employee is an entity. Here the properties of the employees are name, salary, his employee number, his address, his phone number. So those are all the characteristics of an employee. Those characteristics are called as what? Those characteristics are called as a attribute. Okay. And next one is a relationship. So here relationship means association between two or more entities is called as a relationship. For example, let us take two entities like so let us take example for entities like employee and project. So these are the two entities. So there is an association between employee and projects. So what is the association between these two, employee and association? So that is called as works on. So here works on is the association between the employee and the project. Okay. So we can represent this relations or association between the two entities by using the ER diagram. ER diagram means entity relationship model. So in upcoming chapters we will discuss about the ER models or ER diagrams. Okay. Here the representational and implementation models are the models those are used for most frequently in a traditional commercial DBMS. Okay. So in nowadays traditional or a commercial DBMS, here we are using a representational or a implementation models. So let us see the types of data models. These are the categories of models. So let us see the types of data models. There are so many types of data models are there. So some of commonly used data models are hierarchical data model, relational data model, network data model, and last one is the object oriented data model, and next one is entity relationship data model or an entity relationship model. Okay, let us see one by one. First one is a hierarchical data model. So in hierarchical data model, so this one is the in hierarchical database model, this database model it organizes the data into a tree like structures. Hierarchical means one by one. So the data is arranged in the form of a tree like structures. That's why this data model is called as a hierarchical data model. And in this hierarchical data model, this is consisting of a one single it is consisting of a single root. Okay. So in this single root which connects the all datas, remaining datas are connected to this root. Okay. So in the hierarchical form. So in the hierarchy starts from the root data and it expands like a tree like structures, adding a childs to the trees. Those are called as a nodes. And see here I am displaying the one image which describes the hierarchical model. So this is a college database. So this college database is adding the data, or this database uses the hierarchical data model. So here college is a one root. So college data is a root, and here these are the two child of a root node. Those are department and infrastructures. Again we can add the data as a child node to the parent. Now these department and infrastructures are acting as a parent node to the child node, course, teachers and students. Again we can add a child node to the next previous nodes. So this is called as a hierarchical data model. So in this model, child node will only have a single parent node. Okay, these are the child node for the course. Those are having a single parent. Okay. And this model is efficiently describes many real world entities or many real world relationships like a index of a book or any other recipes. Like we can use the index structures to refer a particular chapters. In the same way, we can use the hierarchical database to efficiently access the data stored on the database. And in hierarchical model, data is organized in the tree-like structures with a one-to-many relationship. So there is a relationship that is called as a one-to-many relationship between the two different data types of a data. For example, one department can have a many courses, okay, and these many courses come under a one department. So that's why we can say that there is a one-to-many relationship between the hierarchical data models. And one more example, and many professors, okay, so they can many a department can have a many professors and many students. There is a one to many relationship between the parent and a child of a hierarchical data structures. Okay, this is about a hierarchical data model. And let us see the next one, and see this is a description of a hierarchical database model. We can take a screenshots of this slide or note down. Next one is a relational data model. So this relational data model, in this relational data model, a data is organized in two-dimensional form. That is nothing but a table, as I told you in the previous class. Here, a relationship is maintained by storing a common field. We can establish a relation between the two fields by using a common or by storing a common field. And this relationship model was introduced by a programmer called E.F. Codd in the year of 1970, and since then it has been most widely used database. In fact, we can say that nowadays a database this is the only database which is used around the world, that is relational model. And this is one of the most basic structure of the database in the relational model is, that is, tables. So all the related information is stored in the form of rows and tables. Here the tables are called as what? Those tables are called as a relation. So as I told, this relation or these tables are known as what? Those tables are known as a relational models. So let us take one example. See, this is an example for relational model. See, these are the two tables which are having a student information and teacher information. So this is a student ID, student name and student age, and this is a teacher information which is having a subject ID, teacher by teacher, and this is a name of a subject, and this is the teacher name, okay. And this is a relationship that teaches, which takes a common field, student ID, subject ID, and marks obtained by a particular student, okay. Or that is you can say the relationship name, I can give a relationship name as a report, okay, or a grade report. So in this way we can create a relationship between the two entities, okay. So this is an example for relational model. And next one is a network model. So this this is a network model. This image represents the network model. So in the previous slide we saw the example or image of a hierarchical model. Now we can say that this network model is a extension of a hierarchical model, okay. So in this model, data is organized more like a graph, and these are allowed to have a more than one parent. But in a hierarchical model, a node can have or a child node must have only one parent. But in network model, a child node can have a more than one parent, okay. So in this database model, data is more related as more relationships are established, because the child can have a more than one parent, okay. So hence this data model was used to map many to many data relationship. So this network data model is used to map many to many data relationship, and this was one of the most widely used database model before relational model was introduced. In the last slide we discussed relational model. So before using that relational models, the most used model was a network model. So this is an example for network model. So here vendor is a root node and sales transaction is a last node or a child node which is having more than one parent. Those are employee, customer and product. So these are the three parent to a child. Okay, this is an example for network model. And see, this is a explanation for a network model. And next one is a entity relationship model. So this is a example or a example for entity relationship model. So this model here the object relationships are dividing as a objects. Okay, here the relationship what we are making, here we are making a relation, here we are dividing the relationship as a objects. So let us take one example, that is student. Okay, so the student is the student, here entity is a student, and we are adding characteristics or properties of a student as a attributes to this entities. Okay, those are name, ID, age, and address. Okay, here again you can take a, we can make a address as a one more entity, because address may have a more than one fields like a first name, last name. Okay, so in this way we can add so many attributes or one more we can add some more properties to the address. And in this ER models are defined to represent the relationship into a pictorial form to make easier for different stakeholders to understand the requirements of the users. Okay, so to make better understanding we can use these diagrams. Okay, so for to solve the database problems we can use ER models. The simple we can call entity relationship models as a ER diagrams or a ER models. So this is one of the good design to a database. By using this entity relationship models, we can create a tables into a relational models. Okay, and this is a description about the entity relationship model. And next one is the object oriented data models. So as we know here nowadays to solve the real world problems, the complexity increases. So instead of storing the database as a entities, we are making a collection of objects. Okay, that is called as a class. So for using different object oriented languages, we can access the data stored on the database, that is called as a object oriented database models. And that was designed by one group, that is called as a object oriented or object data management group, which designs the object data model or object oriented data model. So let us see an example for object oriented data model. See, this is an example for object oriented model. So here this is a ER model which represents the database of a customer. Okay, and this is the object oriented model. So here we are adding some more entities by making a class. Okay, but here we are making a separate entities, and we are for those entities we are creating a relation, and after that here we are establishing the association between the two or more entities. So in this way we can reduce the complexities to solve the complex problems. And last one, as I told, that is a physical data models. So that physical data models describes how the data is stored on the files in the computers. Okay, and by that describes or that represents the information such like record formats, record ordering, and access path. So everything that is described by the physical data models, just like indexes of books. And next concepts, that is schemas and instance. In the next class, we will discuss about what you mean by schema, what is the instance, and what is a database states.